Good morning, everyone. Sorry that I'm not here today. I know we didn't have that conversation. It was kind of one of those things where I didn't realize it until Wednesday-ish, Thursday, and would probably have told you on Friday. But we have our new basketball district meeting today, and it's in Fayetteville. So, actually, maybe not Fayetteville. I don't know where it is yet. But anyhow, that's where I'm today, and that's why I'm not with you. So our little day that we had, I told you we kind of had a buffer day, kind of got taken away on Friday, and that's okay. So here's our new plan. Today, we're going to go over Thursday night's homework. Then I'm going to teach normal distribution. We're not going to have class tomorrow because ACT. And then on Wednesday, we'll finish up our statistics. Thursday, we'll review. Friday, we'll take our little quiz slash test. Maybe it'll be like a quest or something like that. But, anyways, I'm going to go through last night's homework since I'm not there to just kind of pinpoint whichever questions it is that you guys have. I'm going to go real fast, though. This one should have been pretty easy. Y'all had quite a bit of time on Thursday in class to kind of get this started. So I'm going to go fast. Number one, it says, what's the estimated population proportion? Okay, remember when we see that word, I told you this is going to be a fraction. So I know I'm setting for a fraction. And we kind of talked about how it's very similar to probability. It's favorable over total. So they are specifically talking about the most preferred candy color from this sample. Well, the most preferred is right here, red, 89. And you put that over the total. So seriously, just grab your calculator, add those up. You should have gotten 196. Now, remember when I was using that example and I told you when they make a statement about population proportion, they don't go 89 out of 196. They will say it as a percentage. So that's exactly what you need to do. So if you took 89 and divided it by 196, you're going to get approximately 0.454. So what they would say is they would say about 45%. That's how they would say it. So that's it. That's kind of how that one is done. Let's keep on cruising. You've recently been volunteering your time, blah, 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 blah. It says at the end, what is the estimated population mean? So mean does not mean fraction. Mean means average. So you're going to add all these up, and you're going to divide by how many there are. Or, like we talked about the other day, you can always go to your calculator. And I'm not going to do that just because of time's sake, but you can always go to your calculator when we talk about mean or average, whatever it is, whatever wording they use. We talked about how you can go to stat, edit. You can enter all of those numbers. Now I have some here. Yours might have some too. I'm just going to go up to L1. I'm going to push clear enter. It erases them all. You can enter all that data. Then you can go back to stat, scroll over this time to calculate, and then you can run a one variable statistics. So we talked about that. Make sure you know those key presses by Friday because I'm not going to tell you when it's time for you to take your little quiz, quest, whatever it's going to be. But anyhow, just for the sake of this particular problem, if you add all these up, that equals 54. There were 6 of them. So it was technically 54 divided by 6, which equaled 9 hours per week. And listen, I know that if you did stat edit, remember, you're looking for X bar. It's at the very top when you run your data. That is your answer. X bar would have been 9. Okay? So real simple stuff. Number 3 may have been a little harder because it's a word problem. It says, which of the following is a correct representation of proportion? And I tried to tell you, remember, when you hear this, they're going to say something like, 65% of all Americans are not pleased with the work of the president. Remember, I told you about that one on Thursday. So which one's written in that manner? That's C, okay? A research firm that 85% of all employees spend an hour eating lunch. That's how you're going to hear that. So that's the one that represents proportion. Keep on cruising along here. Number 4. Number 4 is dealing specifically with average. See, it says the average amount of time that we're spent cleaning the house is 2 per week. And then it specifically goes then into this thing we call the margin of error. Remember, the margin of error basically says this. It's like, hey, we come up with this particular sample with an average of 2, but if I'm going to force this or put this on the entire population, I need to have a little wiggle room. So I'm going to have a wiggle room of 0.018 in both directions. And then that will kind of put me in a category where I feel confident about what this average ended up being. So if you take 2 and you subtract 0.018, that's 1.982. And then if you take 2 and add 0.018, that leaves you with 2.018. So this would be including our margin of error. Real simple problem. Okay, so number 5 on the back side gives you all of these different movies that were seen, and they want to know between what two values am I confident the population mean would fall, and they tell me that I have a margin of error of 4.79 million. So two things I know. One, I need to find the mean. I need to find the average. Again, use your calculator and just add all these up and divide by 1, 2, 3, 4, 5, 6 of them, or use stat edit. I'm okay with either one. If you ran your data, your X bar, or if you added your numbers all up, got a total, and then divided it by 6, you are going to get 41.5. And that's where I'm going to stop. I'm going to round to 1 decimal because all of these are rounded to 1 decimal, and I like to just be consistent. So we're going to say 41.5. So if I'm going to take 41.5 and I'm going to add and subtract this standard of error or this margin of error, here's going to be, you know what, I actually, and for the sake of this problem, let me back up. I'm sorry, I'm gonna change this. Because the margin of error is 2 decimals, I'm going to go ahead and let this round to 2 decimals. Sorry for that quick change, but I think just matching that margin of error would be smarter than even matching these original ticket sales. Okay, so let's go with this. It was 41.53, and my margin of error is 4.79. So just like we did in the last problem, we're going to subtract 4.79, we're going to add 4.79. So 41.53 minus 4.79 is 36.74. And then 41.53 plus 4.79 is 46.32. And there we have it. That's how or where I could really feel confident that the population mean would fall, by simply taking these particular movies, finding the average, and then subtracting and adding that margin of error. Okay? All right, number 6, we're moving right along. This one is also asking about population mean. Population mean. So here are the average fishing time or finishing times in seconds. It says nothing about it says nothing at all about there being a margin of error. So we're simply finding in this particular case the population mean. So however you want to do it, whether you use stat edit, stat calculate, run a 1 variable statistics, or you just want to take these 5, add them all up, and then divide by 5, your X bar or your mean, your average, is 66.8 seconds. All right, moving along, number 7. Which of the following is most like a proportion of a sample? Would it be 95% or 95 out of 100 students prefer Coke to Pepsi? So 95 out of 100 would be like 95%, right? 95% of women surveyed prefer pasta to ravioli. 95 in 100 dogs will develop heartworm without proper treatment. And because of these being out of 100 and the fact that they are fractions, then I would say that all of these would work as far as proportions go, because again, we talked about how it's basically comparing a favorable over a total, and all of those are representing that. Number 8, which of the following best represents a sample mean? The average length of the bridge in America is 500 feet. I mean, that definitely sounds pretty good. It says average length. That's mean. It's found that on average, 53% of voters. No, that's more like proportion. TV shows average about 22 minutes for every 30 minutes. See, that's more of a fraction. That's more of a proportion. So B and C are more of a proportion. So there's no way it's D. We're going to go with A. We feel real confident because the way that one's written that it's A. All right, last problem, and I think you guys probably have done really well on this, I would assume. Y'all are so smart. This one, the last one, talks about population proportion. So immediately I know, all right, I'm writing a fraction here. So let's see what our fraction is going to be. Hot and spicy. Hot and spicy. So hot and spicy is right here. That's 26 of them. And then, of course, what are we putting that over? The total. So you just add all those up, and that's 124. So when you type that into your calculator, 26 divided by 124 works out to be about 0.209. So we're going to say about 21%. 21%. Okay? So there you have it, guys. That's population mean and population proportion. We talked about both of those. At this point, you should be very, very clear on the difference between proportion and mean. But we also talked about one other thing, and that is the margin of error. So those three are the main takes from that lesson. I think it was pretty easy. So at this point, you should have already received your normal distribution note sheet and probably even the homework too. You just don't know which ones are going to be homework and which ones we're going to do in class, so you kind of have to wait on me. Sorry. But since I'm not here, that's just the way it's going to have to be. So this is the note sheet. There's 3 pages really. There's a front and a back and then an extra page. You're going to probably do that last page. If you feel really comfortable about this and you want to kind of roll along, that last page is going to be what you're going to have as your homework assignment. We're going to do quite a few examples together. This is not necessarily a difficult concept, but I do hope that you pay attention. So basically, in a nutshell, when we're gathering data, there are really 3 main ways that you can see when you've accumulated all your data. There's 3 major ways that you can see your data. These 2 here are a little less often occurring, honestly, and this one's the most often occurring. That's why basically this entire lesson. This one right here, when you have more to the left and less to the right, this one would be called positively skewed. So I bet you can guess what the one on in the middle is. When it's got more to the right and less to the left, yep, that one's going to be negatively skewed. And those, honestly, when you're collecting stuff, collecting data, those are less occurring than this last one. This last one, obviously, the majority is right in the middle. You have very little that are on these outside edges. Very little. And it does this little, like this little up the hill, down the hill kind of move. This we call normal distribution. Normal distribution. And honestly, let's say I was going to give a test, and I were to take all the kids who took this test, and I were to grade it, and then put them all in an order, and decide to average them all out, put them in a table of where they all fit. More than likely, it's going to be like this. Now, if it's a really, really, really simple quiz, it might be negatively skewed. If it's a miserably, miserably hard test, it might be positively skewed. But just a normal test is normally going to fall under this last category and be normally distributed. So we also will refer to this sometimes as a bell-shaped curve. A bell-shaped curve. And when we collect data over a lot of things, they fit into this category of a bell-shaped curve, where the majority of your values are going to be found right in the middle, and then they get a little bit less as they go to the left, and they get a little bit less as they go to the right, until finally you have very little on the outside. Normal distribution, and we refer to this as a bell-shaped curve. Now, the area under the curve represents probability. And therefore, that total area that will be under the curve is 100% or 1. Y'all know that 1 is 100%. You're going to have 100% of your data under this curve, okay? Now, here's the rule. This is what your normal curve looks like. And right smack dab in the middle, you have this mu thing. Remember what we called mu? We called this our population mean. So you're going to put your mean right smack dab in the middle. Now, it kind of works in the opposite direction. It kind of works the same as margin of error. But instead of using margin of error, they use this word called standard deviation. Standard deviation is, on average, how far away I am from the mean. One more time, I'm going to say that. Standard deviation is, once you've collected your data, a standard deviation is how far on average you are away from the mean. So when we talk about a standard deviation, it works so much like margin of error. You find that standard deviation, kind of like we were given that margin of error, and you're going to subtract it from the mean, and you're going to add it from the mean. And underneath that category, that includes one standard deviation away from your mean, that is going to include 68% of all your data. 68% of test scores, or 68% of your population will fall one standard deviation away from your mean. So what does that mean then? If 68% is one standard deviation away from the mean, that means that 34% lies to the left of that mean, and 34% lies to the right. Okay, that's 68 divided by 2. I didn't do rocket science there to come up with those numbers. I simply divided it right by 2, because you got equal amount on both sides that are one standard deviation away from that mean. Okay, now, how about 2 standard deviations? 2 standard deviations away from your mean is a ton. It's 95%. Now think though, how much is already accumulated for? So we already talked about the 68%, right? So we're only talking now about 95%. So 95% minus 68% equals what? 27. 27% are in these 2 categories that are 2 standard deviations away from your mean. We're talking about here and here. Remember, we've already talked about 68%. But 95% are 2 standard deviations away from the mean. So if we subtract that 68% that we've already accounted for, that are 1 standard deviation, that leaves us with 27% in those 2 categories. Well, divide that by 2. That means 13.5% fall here, and 13.5% fall here. There you go. All right. Now, 3 standard deviations away from your mean. 3 standard deviations is almost the rest, okay? It's 99.7. 99.7. Remember, I told you, well, we'll get to that in a second. I'm going to pause on what I was about to say there. So 99.7 fall from this line here to this line here. Now remember, how much have we already accounted for? We've already accounted for 95%. So that means we have 4.7% Okay, 4.7% lie here and here. So let's divide that by 2. 4.7 divided by 2 is 2.35. So we got 2.35% of the population who lie here, and we have 2.35% of the population who lie there. Now, remember, underneath this normal curve, underneath this bell-shaped curve, we have 100% of the people, right? Or the population. Well, we've accounted, 3 standard deviations have accounted for 99.7. So that means there's a measly little 0.3% who we have not accounted for. And that 0.3% lay right here and right here. 0.3% lie in those two spaces. 0.3% divided by 2 is 0.015. 0.015% of our population lie in those two spots. You know what we call those in the past? Those 0.3 percenters that are either way at the bottom end or way at the top end, we call those our outliers. I know y'all have heard that word before. That's those people. Those are the people who they didn't pay attention in class when they took the test. Maybe they fell asleep and didn't even take the test. Or that might be your crazy person who studies all the time or just is brilliant, and every time they come and take the test, they make this insane grade on it. Those are your outliers. Okay, when everybody else falls 99.7% within 3 standard deviations from the mean, these people are the ones that are just way out there. Crazy, okay? So that is what we call normal distribution. Those numbers are numbers that you need to be very familiar with, okay? I don't know how you're going to memorize them, whether you want to remember these numbers up here and then just divide these, or then subtract and divide, or if you want to just remember one side of these and just duplicate it on the other side. I don't care how you memorize these, but you need to memorize those by Friday, okay? It's not hard. That's not hard. You can do it. So let's talk about this as far as the rest of it goes, okay? I might understand all of this stuff on the inside, but what about this stuff down here? This mean and these things we call standard deviation. Well, remember when I showed you how we can run that one variable statistics thing on stat calculate? Well, in that, they're going to give us our mean. It was x bar, not mu, but it's still your mean. And then sure enough, in that, they do give you the standard deviation. So it's just like margin of error from Thursday. You add it and you subtract it in both directions, and that's how you set up your normal curve, your normal distribution, and then you can answer any question that happens from that. Okay, so let me show you a particular one, and here's what I'm going to encourage you guys to do. Immediately, I would encourage you to go like this. I would encourage you to go 34, 13.5, 2.35, and 0.15. And then just do it in both directions. Just go ahead and get that out of the way, okay? Before we even look, we know this problem is talking about normal distribution because they draw me the graph and they say the weights of 50 football players are normally distributed. That's how I know we're doing this. Now, what does it tell me about the mean? The mean, the average is 178 pounds. So we are going to slap that 178 right in the middle. That's your average. But then they tell me that my standard deviation is 8 pounds. Well, there it is, guys. That is, in a way, that's your margin of error, if you will. Okay? Your standard deviation, you treat it just like that. So if I want to go one standard deviation to the left, what am I going to do with 178? I'm going to subtract 8. Well, 178 minus 8 is 170 pounds. Okay? Now let's keep on going. Let's go one more standard deviation to the left. So I subtract 8 again. That's 162. Let's go one more, subtract 8 one more time, and we're down at 154. If I go to the right, we're going to add 8. 178 plus 8 is 186. If I added 8 more, that's 194. And if I add 8 one more time, that's 202. So now we've got everything labeled. We can answer any question they want to ask. Okay, for example, look at A. What percent of the players weigh between 178 and 194? Now, fortunately, I can highlight on mine where you can't. So I'm going to do just that. And then you are going to see the answers by, adding up your percentages. So look, 178 was right here. And we're going to 194. That's right there. So we're talking about these two groups right here underneath our normal curve. So all they want to know is, hey, well, what percentage is that? Right? What percent? That's what it says. What percent of those players weigh from 178 to 194? So we just add. That's 34 plus 13.5%. Well, 34 plus 13.5 is 47.5%. Done. That's it. Now, again, I can erase those. You can't. Maybe you could lightly color and then erase it. Now, look at the next one. What's the probability that a player weighs at most 170 pounds? 170 pounds at most. That means 170 is the most they could weigh, correct? 170 is the most. So that means 170 and below. So we're talking about from this line all the way to the left. So who all does that include? Well, it includes 13.5, 2.35, and 0.15. So if I add all that up, that's 16%. That's the probability, right? Probability. If we could do a fraction, we would. It's 13.5 plus 2.35 plus 0.15 over 100, right? Which is 16%, 16 out of 100. So that's how we write it as a probability as well. Okay, easy stuff. Let me erase that, and then we'll move on to the next one. And here's what it says. What is the probability that a player weighs less than 162? Okay, here's 162. Let's go here and below. Less than that means down in here. Or greater than 194. Greater than 194. So 194 is here, and everything greater than that. So on the left side, we're talking about 2.35 plus 0.15. That's 2.5. And here we're talking about 2.35 plus 0.15. That's 2.5. So 2.5 plus 2.5 is 5%. 5% live in those two categories. All right, last question. Last question's asked just a little bit differently. I want you to pay attention. The last question says, how many players? See, it doesn't say what percent of the players. It doesn't say what's the probability that a player. It says how many players weigh, it should say weigh, between 170 and 186. So first of all, here's 170 to 186. That's these two categories, right? Well, guys, that's one standard deviation from the mean, right? That's these two categories. That's one standard deviation. That's 68%. That's 68% of our players, right? But remember, they don't want to know what the percent is. They want to know how many players. So here's what you're going to do. You're going to type in your calculator 0.68, because that's 68%. 0.68 times, how many total football players were there? There were 50. So we're going to do 0.68 times 50, and that's going to tell me 34 players. So please just be careful when you see these problems. Make sure you put them in the right perspective, because sometimes it'll say percent, sometimes it will say how many, like specifically. So you have to then take it and do the math. Okay, real simple. All right, what do you think? I hope that you guys are understanding this. It's actually quite simple. Once you have a good grasp on that and putting your mean right in the middle and then adding and subtracting that standard deviation in both directions, it really is quite simple. Okay, normal distribution. Really not meant to be a crazy hard lesson. So let's do another couple problems real quick and then I'm going to call it a day. Here's what I like to do really fast. 34, 13.5, 2.35, 0.15. Just write it quick, then you can do the other one. It's the identical thing in the opposite direction. Now you can read your problem. A set of 120 test scores are normally distributed with a mean of 82. Okay, tell me, where does that go? Right smack dab in the middle, 82. And a standard deviation of 5. So what are we going to do with 5? We're going to subtract it and add it in both directions. So 82 minus 5, 77. Minus 5, 72. Minus 5, 67. Go back the other direction. 82 plus 5, 87. Plus 5, 92. Plus 5, 97. And now I can answer any question they ask me. So here we go. And again, I'm going to use my highlighter just so if you're still struggling with this in any way, you'll be able to see it for a couple more problems. So from 70, what percent of the scores are between 72 and 87? So there we have it. Let me get this all highlighted nice and pretty. And then we can tally those up. Again, when you're doing this on your own, you're not going to have to do as much highlighting, and you should be able to go a lot faster than me. But anyhow, that's 34 plus 34. That's your 68, one standard deviation for the mean, plus 13.5. So that is 81.5%. Okay, erase. B, what's the probability, okay, so again, percent, that a score is greater than 77? So here's 77, guys. And, oops, I hate when I do that. 77. So here's what I like to do on this one. Isn't that from the dead middle all the way over? Isn't that always 50%? So instead of adding up every one of my categories, I'm just going to go 50% plus 34%, right? Because you got all of this is 50 plus that 34. So 50 plus 34 is 84%. Now, listen, there's nothing wrong with going 34 plus 34 plus 13.5 plus 2.35 plus 0.15. But if I can just remember that from this point over is 50, that's 50 plus 34, 84. Okay, C. What's the probability? So once again, we're doing percent. Probability that a score is less than 82. Okay, so less than 82. Well, that's 50%, right? All of this, less than 82, that's 50%. That's easy. Or greater than 92%. Or greater than 92. I'm sorry, I said that wrong. Well, greater than 92 is 2.35 plus 0.15. That's 2.5. So it's 50 plus 2.5. 50 plus 2.5 is 52.5%. Ooh, that didn't come out all good. 52.5%. Last one, let me erase these highlighters. Last one says about how many students. See how it asks a different question? Not percent, not probability. How many students scored outside 2 standard deviations of the mean? Okay, it's asked a little differently. Outside 2 standard deviations from the mean. Well, remember, 2 standard deviations from the mean mean 1, 2 standard deviations. So outside of that is here, and outside 2 standard deviations that way is all of this here. So outside 2 standard deviations include those 2 segments over there that are outside 2 standard deviations. So that's 2.5 plus 2.5. Well, 2.5 plus 2.5 is 5%. But remember, this doesn't say what percent or what probability of the students. It says how many of the students, right? How many of them. So we got to do this a little differently. We've got to multiply 5%. Now be careful. How do I multiply 5%? Remember, you move your decimal 2 to the left. That's 0.05 times, how many were there? 120. 120. So 0.05, 5% of 120 is 6. 6 students scored outside 2 standard deviations from the mean. Okay? So that's really all there is to it. I mean, it's pretty straightforward. I've been going now for about 36 minutes. We don't have a ton of time left. And I'd like to give you a little bit of time to do your homework. So I think with those examples, you should be set to go. So here's your homework for tonight. I want you to do numbers 7 through 10. Okay, 7 through 10. So my recommendation down here on number 9 and 10, you might not want to draw your own. You might just want to, underneath these two, so underneath number 7, maybe do number 9's numbers. And then underneath number 8, maybe do number 10's numbers. Instead of actually having to draw them and do them yourself, you can just use these nice diagrams up here because you got plenty of room underneath it. So you could do number 7 and number 9 here. You could do number 8 and number 10 here. And then you could put your percentages inside. But anyways, this is your homework, number 7 through 10. Due on Wednesday when we come back together after the ACT. Hey, I hope you have a great rest of your day, and I hope that you do awesome on the ACT test tomorrow, or the pre-ACT if that's what you're taking. All right, well, y'all have a great Monday. See you soon.